Students, good morning. Today I am going to take a class on rate of drying curve. Rate of drying curve. Before going to define this principle behind the rate of drying curve, I am going to perform a simple experiment. Take a known shaped, definite shaped solid brick. This is called as brick, mud brick. Okay. Its size is known, length, breadth, width. So length, breadth, width. Three parameters are known, so it is easy to find out the area. That means 2 times of L into B plus B into W plus W into L. So area of the brick is known. That means exposed area to the atmosphere is known. Next parameter, now I am going to take the weight of the sample. Weight of the solid. This weight is dry weight. So dry weight is also known. And take a glass beaker with known amount or certain amount of water. Now I am going to drop this brick into this liquid water. After enough time is allowed, remove this brick and go for again weight. Now the weight is wet weight of the wet brick. Weight of the wet brick. Weight of the wet solid. So area of the brick A is known, dry weight and wet weight both are known. Here the difference in dry weight and wet weight is moisture content. Moisture content means moisture content. In my previous video lesson I am discussed about the moisture content. Moisture content is nothing but amount of water present in the wet substance or moist substance, wet solid or moist solid. Say for example, the dry weight is 50 grams. Dry weight is 50 grams. Wet weight is 65 grams. 65 grams. So the moisture content present in the solid is 15 grams. It is the enough parameter not to discuss the rate of drying curve. Right, clear? Right. Now I am going to perform a simple experiment. The weight of the wet sample is 65 gram. Weight of the dry sample is 50 gram. So moisture present in the wet substance is 15 gram. Hang this wet material in a weighing balance. Every 1 gram of weight loss, note down the time taken. Amount of time required for 1 gram of weight loss. This is the observation table. In this table, first column serial number, second column weight of moisture, and third column time taken in minutes. Weight of moisture in grams. Convert this in terms of kg. Later on, you have to convert this in terms of kg. This is in terms of second. First reading. Initially, weight of moisture is 15 grams. Time taken is 0. Second reading, 14 grams. That means weight loss. 1 gram of weight loss. What about the time required? So note down the time. Third reading, fourth reading, fifth reading. Again, 13. 12, 11, 10 and so on. Again the dead 10. It is not possible to bring 0. So stop your experiment up to 1 gram of moisture or 2 gram of moisture. Whatever is convenient for you, you have to stop the experiment. Now observation table is ready. Okay. Next, rate of drying, and I am going to draw the rate of drying curve. For that, make a plot. In x-axis, take time. In y-axis, moisture content, most probably on dry basis. Moisture content on dry basis. Clear? Now the reading is, the graph seems to be like this. This is one segment. This is one segment. This is another segment. This is another segment. This is another segment. Now I am going to label the changes in graph. Now I am going to label the changes in slope of the graph. See, this is A to B. This is point A and this is point B. This is B to C. B to C, and this is C to D. C to D, and this is B to E. Clear? You can see that the slope of the curve changes continuously. This is a type of slope. Again the slope is changed. Again the slope is changed here. Again the slope is changed here. A to B. The section A to B is initial adjustment period. Initial adjustment period. In this period, see this wet sample. It shows drop down of water droplets. Now I think this is the final drop. This is the final drop. Okay, this is the final drop. See this, a thin film of water layer. A film of water layer is surrounded on this wet brick. A film of water layer is surrounded on this solid brick. The last drop to this stage, this is called as initial adjustment period. Now I am going to place this wet brick in a stream of rapidly moving hot air. In this situation, in this initial adjustment period, the solid substance, temperature of the solid substance goes to increase to a little level. So initial adjustment period means this is the period where a small increase in temperature of the wet brick. So A to B is the initial adjustment period. B to C is the constant rate period. B to C is the constant rate period. Constant rate period. And C to E. That means C to D and D to E. In both cases, falling rate period. Falling rate period. C to D is the first falling rate period and D to E is the second falling rate period. For better explanation, I am going to draw the rate of drying curve against moisture content. One more graph, rate of drying curve against moisture content. Listen, see here, make a plot. In x-axis, take moisture content. In y-axis, rate of drying or drying flux, that means kg moisture evaporated per second. This is the rate per unit cross sectional area or per unit area of the wet brick, centimeter square or meter square. This is flux for drying, rate of drying against moisture content. See, initially we have more moisture. In this drying process, moisture goes to decrease. So this is the point. This is initial adjustment period. That is A to B. After B, there is a horizontal portion till C. This is C. From C, there is a falling rate period. This is first falling rate period. This is second falling rate period. Clear? First falling rate period, second falling rate period. This is horizontal portion. This is a horizontal portion, C B to C, and this is C to D. First falling rate period. D to E is the second falling rate period. This is the rate of drying curve. A to B is the initial adjustment period. B to C is the constant rate period. Constant rate period. What is going on here? What is going on here? Two important informations. One is after this initial adjustment period, a fine film, a thin film of water layer is surrounded on the outer surface of the brick. Clear? Now drying is going to happen. During drying, just listen, amount of moisture moved from inside to outer surface of the wet brick. Listen, amount of moisture present within the wet brick moves towards the outer surface. It is equal to amount of water vapor present at the outer surface gets evaporated. That means rate of evaporation is equal to rate of moisture movement towards the outer side. In concentrate period, rate of evaporation is exactly equal to rate of moisture movement towards outer surface. The rate of drying is constant. Are you able to clear? Initially, a thin film of water, a thin layer of water is surrounded all the 6 sides of the wet brick. During drying, the moisture present inside the wet brick moves towards the outer surface. Again, listen, rate of water present in the, that means water present in the outer side, that is called as rate of evaporation. That is equal to rate of moisture moved towards the outer surface. Rate of evaporation is equal to rate of moisture movement towards the outer side. So this period is called as constant rate period. Constant rate period. One more important point. I am keeping this wet sample in a stream of hot air. From bulk air to top surface of the outer surface of the wet brick. Heat gets transferred from this bulk air. Heat gets transferred from bulk air from bulk air to surface of the solid. Rate of heat transfer from bulk air to surface of the solid is exactly equal to rate of heat required for evaporation. Rate of heat required, rate of heat transferred from bulk air to outer surface of solid is exactly equal to rate of heat required for evaporation. Clear? Two important points in concentrate period. First point, rate of water evaporated is equal to rate of moisture movement from inside to outer surface. Point number 1. Point number 2, rate of heat transferred from bulk air to surface of the solid is exactly equal to rate of heat required for evaporation. These two important points in concentrate period. Next, falling rate period. C to E. Listen. In this period, the top surface will no longer be covered by the film of water layer. In falling rate period, there is no longer covered by water, film of water will no longer covered on the outer surface. Here, rate of evaporation is greater than that of rate of water evaporated on the top surface is greater than that of rate of moisture movement from internal side to outer side. Clear? Two process. One is water evaporated from the top surface. Another one is rate of moisture movement from inside to outer surface. During falling rate period, the outer surface covered no longer with the film of water layer. Rate of evaporation of water or moisture from top surface is greater than that of rate of moisture moved from inner surface to outer surface. Are you clear? In falling rate period, falling rate period, rate of moisture evaporated from outer surface of the solid will not be equal to rate of moisture movement from or towards the outer surface from inside of the solid. Here, hence the rate of drying goes to decrease gradually. This is called as falling rate period. In falling rate period, the rate of moisture evaporated from the outer surface will not be equal to the rate of moisture moved towards the outer surface from inside will not be equal. Rate of evaporation is more than that of rate of moisture movement towards the outer surface. Important point. Next point, rate of heat transfer from bulk air to the surface of the solid will not be equal to rate of heat required for evaporation. In falling rate period, we have two segments. One is first falling rate period, second one is second falling rate period. The first falling rate period is controlled by unsaturated surface drying. This period is called as unsaturated surface drying. Unsaturated surface drying or capillary action. The first falling rate period is governed by unsaturated surface drying. The second falling rate is governed by liquid and vapor diffusion process. We will see it later. Clear? This is the principles involved in rate of drying curve. The first curve is plotted against moisture content on dry basis in y-axis, time in x-axis. The curve of the slope of the curve gets continuously varied from A to B, B to C, C to D and D to E. A to B is nothing but initial adjustment period. It is very short span of time, you leave it. It does not have much significance. B to C is the significant period, this is the constant rate period. C to D and D to E are the falling rate period. C to D is the first falling rate period and D to E is the second falling rate period. This is clearly indicated in this graph. In y-axis rate of drying, that means kg per second meter square, rate per unit area, heat drying flux. In y-axis moisture content. Clear? B to C is the constant rate period. End of the C is called the critical moisture content. And end of the E is the equilibrium moisture content. We will discuss it later. Thank you. Thanks, Ravina.